Hello, welcome to a video about higher order array functions. So I just made a bunch of individual videos with kind of some non-real, some like made up scenarios to cover map, sort, reduce, filter, and fill. And I thought there might be a way of making use of all those functions to improve, I don't know if it'll really improve, but to change, to adapt my coding challenge number 78. Simple particle system. So this is the coding challenge. This is the code. It's got an array in it. I'm doing everything rather manually with a loop. What can I do to use these functions? So let's start with fill. So the first thing I want to do is, let's see if I can use fill to start the array with like 100 particles. All right, so let's see. Let's start by saying the, whoops, what happened here? Let's start by saying particles is a new array with 100 spots. Now, in theory, what I kind of want to do is this, particles.fill new particle, right? I want to just say, hey, fill all the spots with a new particle, and I already told you there's 100 spots there. This is kind of going to do something interesting. I'm going to actually, just to demonstrate, I'm going to take out adding particles in draw, and I'm going to run this real quick and say, like, oh, did you see something there real fast? Look at that, real fast. What was that? Well, actually what it did is it made a new particle and it put that new particle in every spot in the array, but it's all pointing to the same particle object. I need a different particle object in every spot. So in this case, I've actually really got to use the map function. So I can fill the array with like emptiness and then use the map function to create a new particle for each and every spot. So what I could do here is I can just say fill dot map, and then each element, I'll call it P, should be a new particle. So this now should give me, whoops. So why didn't this work? Okay, so here's the problem. I forgot. I don't know, maybe this isn't the greatest thing to do because map requires a new array, so this is all sort of silly that I'm doing here. So it would make more sense for me to say this, because why make a new array twice? So what I want to do is make a new array, fill with nothingness. I could put null in here, and then map. Oh, I don't like where this, and then map to new particles. I hate this. There, that worked. I got a little burst of 100 particles. Can I take out this null? Yes. So I don't know. Do we like this? This is almost ridiculous. I don't know if I really need this, but it works. I have a particles, which is an array of 100 particles, and each element is a new particle object. And you can kind of see that one line of code. Great. Okay, so we used, in this video, we now used fill. Oh, and we used map. Oh, how lucky for me. And again, I've really got to pay attention to what just acts on the current array, what makes a new array. All right, so what can I use next? Let's go ahead and use filter. I'm going to show you something interesting about filter. So if you've watched this challenge and looked at this code, look what I'm doing here. I have this very awkward loop that loops through the array backwards. Using the index, I access each element of the array, I update, I show, I check this finished function. If that finished function returns true, I use the splice function to remove it out of the array. So I can really improve this. Let me add this back in, where it adds 5 new elements to the array. And maybe there's a way I can do that with one of these higher order functions. There we go. Now we can see here's the particle system. One thing I could do to improve this is let's just use the for of loop. So for every particle of particles, this is a loop that's part of a loop structure that's part of the JavaScript ES6. I have a whole video just about this loop. It's saying every single element of the array, reference each element in the variable particle. So I can just say here, particle.update, particle.show. So that's nice. I like that already better than this down here, which I'll comment out. So this is a nice, simple way of iterating through every element. And there we go. I probably should use the for each loop since this is about higher order functions. So we can see this is the same. But now, let's look at particles.length. 1975, 2001, It's not deleting any of the particles as they fade out. So how can I do that? I can say, instead of having to check each one and remember the index and use splice, I can now say particles.filter. And what do I want to filter? Now remember, I can write the function to return true or false to tell it whether to keep it or not. If you watched my video on filter, all in line using the arrow syntax. So really what I'm trying to write here is I want to write a function like keep, and it receives a particle, and I'm going to return p.isFinished, right? And ultimately, I want to keep it if it's not finished. So this is the function that I want to write to filter everything out. It returns true if it's not finished, so keep it. But I can just write this as and not. So look at this. Now, and I have to remember, on my list, filter is one of those ones that returns a new array. So this actually isn't going to do anything unless I say particles equals particles.filter. Filter them all out based on the isFinished property. And now, okay, isFinished is not a function. I just called it finished. Okay. And there we go. Now, is this really working? Let's check. Particles.length, 255, 255. It makes sense that it's always 255 because its lifespan starts at 255 and goes down by 1, and I'm adding like 5 per frame. Somehow the math works out that it's like nicely 255. That's very interesting. All right, so look at this. Now, the reason why, this particle system example is a bit of a simplified version of my nature of code ones. I just want to really briefly go to github.com/Schiffman/the nature dash why is code dash examples dash p5.js. So if you want to see more examples that do this, and I go into chapter 4 systems, I have a lot of particle system examples. Here's one with systems of the particle system class. You can see I am now doing this in my examples with some extra comments. So this is now, if you want to see many more examples where I'm kind of using this type of ES6 style to operate on an array of particles, you can check out these examples as well. What else can we add to this? Let's use reduce. So let's see if we can use reduce. So one thing that I might want to do with reduce is something that happens in my flocking examples, for example, is I want to calculate like what's the center, what's the average location or the average velocity of everything. So let's compute what's known as the centroid, which is a term for the average location of a position of a collection of things, the center of it. So let's think about how I would do this. I can get rid of all this now. So I want to say particles.reduce. And remember, reduce always gets an accumulator and a particle. Right? There's an accumulator and a particle. And what I want to do is I want to add up each particle's location. So there's a bunch of different ways I could do this. For example, I think it might be simpler right now to just do it with the x and y. So first, let's just calculate this x. I'll call it Cx for center x. And this is going to be, I'm going to call this x. So the x is just to have like shorter variable names. X is the accumulator. P is each particle. So what I want to do is say x plus p dot x. Right? I want to add up all the x values of p. This is not going to work, right? Because remember, if you watch my reduce video, the accumulator has to have an initial value. If you don't specify, it's the first element of the array. Well, what's the first element of the array? It's the particle object. So in this case, I can't like add the x value. I want the first element of the array to be the first particle's x value. But what would be simpler here would just be to explicitly initialize it at 0. So I can then say just comma 0, and this should give me the center x location. Right? I'm adding up all the x values. Now I need to divide by the length, but so this is really sum x, I'll call it. The sum of all the x values. This would be sum y. And I'm going to do this and And just to rename the variables, I'm going to do this. Right? And then I should be able to say center x equals sum x divided by particles dot length. And center y is sum y divided by particles dot length. And let's just draw a nice red circle right there. And see what this looks like. Let's see if I got this right. There we go. You can see that's always the average center of all the particles, the centroid of all the particles. So again, what have I done here? I could have written a loop. I could have said sum x equals 0 before the loop. Every element of the loop, I say sum x plus equal the particle.x. So I don't know, have I improved anything? But this is a way that you could write it using a higher order function called reduce. Now, could I do this in one line? Could I do this without separate x and y values? And I can. Let's look at that. So one way I could do that, you know what, though the particles don't have vector objects. So I might almost want to leave this as an exercise. I'm going to leave this in some way. So what I would say is like go to, where was that? Where was that? Go to this particular example, right, where I'm actually, here, each particle, if I go to this example in Nature of Code, and I look at the particle object, the elements are actually P5 vector objects. So how would you write this function to add everything up with a P5 vector? So I think we could actually do this here. Let's do this here. Okay, so let's say I were to say, I'm going to comment this out. I'm going to say let sum, I'm going to say sum v, which is the vector sum, be create vector 0, 0. That's the accumulator. Right? That's going to be that's the accumulator. I'm going to make an empty vector at 0, 0. Then I'm going to say, I'm going to call this accumulator v. Then I'm going to say let sum v equal, I'm going to do the same exact thing. Particles reduce this accumulator, which is v, which is going to be a vector, p, then say v dot add, because I'm going to use the p5 vector syntax. Whoa, this is really crazy. P dot x, p dot y. So I believe the P5 vector object has an add function, and I can add to the vector the x and y components directly. And then I'm going to give this as the initial value of the accumulator. So really what I probably want to do is just put this right here, be a little less confused. But this is a super, this is like a crazy one line of code. I can't even fit it on the screen here. There we go. Right? I'm reducing, let's see if we got this. I'm reducing the array. I'm going to accumulate a bunch of vectors, with the first vector being an empty vector with 0, 0 in it. And then for each one of those, I'm going to add to it each particle's x and y. And then I'm going to say, I know I'm standing in front of the code right now. I'm going to say sum v divided equal particles.length. Oh, I can't do that. I have to use, it's a vector, I have to use the divide function. Divide by the total number of particles. And then I'm going to say sum v dot x and sum v dot y. So let's see how this goes. Are you actually still watching this video? Because I'm like going off the deep end with all these things. I'm never going to. Okay, let's go back to my sketch. Same result. So that's working to calculate the centroid. So you've seen now I can use filter, I can use reduce. Let's look back at the list. Filter, reduce, fill, map. Still have sort. So this video is just going to be longer. I'm going to use sort in this video. So here's the thing. I don't think that the code is necessarily going to run faster or more efficiently this way. And this could be a problem if I have a particle system with thousands, hundreds of thousands, millions of particles. I really want, probably then, a simple for loop is going to actually execute the fastest. But there's something nice about learning how these functions work and sort of seeing how this can be done, because you will especially see these in libraries that are manipulating large amounts of data, in JavaScript libraries that are kind of using this sort of style of coding. So hopefully this is helpful to you. Let's do sort. Why would I want to sort these particles? Well, one reason might be, what if you're first of all, if you're actually in 3D space, it's sometimes advantageous to know the Z order of things, because you might want to draw them in that order related to how the alpha or the blending and various things are working. But I'm not in 3D. But even in 2D, what if I wanted to have some type of layering system where I always wanted certain things to be drawn over other things, even if they're out of order in the array? Because right now, I'm only going to draw things in the order that they are in the array. So let's create kind of a fake scenario that will do that. So what I'm going to do is I'm going to go to the main sketch, a particle, and I'm going to add, I'm going to go to particle, and I'm going to add, I already did this actually. I'm going to add a color variable, which is just a random brightness value between 0 and, I guess technically this can be random 256, because I can get 0 through 255. And then I'm going to fill by this dot color, and I'm going to get rid of the alpha. So there's going to be no alpha now. Let's look at this. Whoops. Let's go back. I'm going to run this. And I'm going to get rid of the centroid, just so we don't have that big red dot for no reason. I will obviously leave this in the code. Go back to here. Now look at this. So there's obviously a layering going on here. The layering happens to be just the order that the particles were added. But what if what I wanted to do, for example, was always have the brighter ones appear on top of the darker ones? I don't know that that will produce any visual value, but you could imagine a scenario where you're actually thinking about layers and depth. And maybe you create fake Z variable for each object or something like that. So I could sort them by their brightness. So let's look at that. If I go now back to Sketch, before I draw them, I could say particles.sort. And remember, when I sort, I need to create a function. And again, I'm using this arrow syntax just almost automatically now. Is this working for you? Please let me know. All these videos help you kind of just see it, where I start with two elements of the array, A or B. And now it's up to me to return a value that says which one should be before the other. And so I can actually just say A.color minus B.color. Because if you return a positive number, a negative number, that means positive number means one is before the other, negative number means the other is before the other, and then 0 means they're equal. That's how you're telling it to sort. So this should be a way of sorting the array. And sort actually manipulates the existing array, not making a new one. So this now, if I run this, we should see, look at that. The brighter ones are always on top of the darker ones, which is kind of an interesting effect. Again, you know, you could probably invent your own scenario of layering as to why you want to do this. But now we have a particle system, coding challenge 78, that has map and fill to create an initial set of particles. It has sort to sort the way I'm drawing them based on brightness. I'm using a for of loop to be able to iterate through all the particles. And I'm using filter to filter out particles that I no longer need, that have faded out. As a bonus, I think it would be interesting for me just to try to use for each. I've never actually used it, right? So I could also say, if I really want everything to be a higher order function, I could say particles for each, right? And then I could say this. But I need multiple lines of code. So I'm going to say p.update. All the laws of physics are like exploding around in my head as I'm using a for each loop. I can't believe I'm doing it. So is this right? Let's just run this. Hey, and let's put the centroid back in. There we go. So I can't believe I just did this, but a for each loop, what a for each loop does is says, apply this function to every element of the array, and my function is to update and show. If, incidentally, because I have two lines of code, I have to write out the full curly brackets, but I could do this. I don't know what the point of this would be. But if I just wanted to write it like this, just to be like kind of a crazy person for today, I could say update all of them, show all of them. And sometimes you actually want to get through updating all of them before you draw all of them. So this would do that. Let's see. And there we go. I'm like, am I a function? Do I qualify as a functional programmer? I seriously doubt it. But I have gone through and hopefully shown you a bunch of techniques for applying the arrow syntax and functional higher order functions of JavaScript arrays in this video. Hopefully you learned something. It will improve or help something you're doing in the future. Please let me know in the comments, and thank you for watching.